Hello, my friends and fans of Living Environment. We're here for another day and another Bellringer. And of course, we're studying expression of genes, genetic expression. And today you'll be reintroduced to a character you may remember from previous studies, a man named Mr. Gregor Mendel. All right, well, let's do the Bellringer here first.
All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class.
As you know, it's been hard for me to admit that I have this terrible mutation. I am not normal. I don't have the right color eyes to be human. Mine are not dark brown, they're blue. They're all out of human history. Eyes are brown. And it wasn't until one mutation showed up about 6,000 years ago that anybody showed up with eyes any other color. And now 8% of the population, a very small, less than 1 out of every 10, fewer than 1 out of every 10 people has eyes that are not brown. It's weird. And I'm proud to say that I'm now comfortable with facing my mutation. I know it's not my fault. It's my parents. Of course, this is a mutation of a gene, and a gene codes for a protein. And the proteins just happen to be the ones that code for the color of the iris of your eye. Weird. Right? And then we get genes are found on a piece of DNA that are bundled up during meiosis into what are called chromosomes. And I think we just determined that there are 23 human chromosomes. You just happen to have 2 of each for a total of 46. You get half from the egg maker and half from the sperm maker. But you get 2 copies of each one from mom, one from dad kind of thing. Right? And I think I mentioned yesterday, chromosome 15 is where this mutation occurred. Chromosome 15 is a medium-sized chromosome. It's got lots of genes on it. But one of the genes is, of course, to make melanin, this protein that makes dark. It's like this dark brown pigment protein. It's essential for protecting you from ultraviolet light. Right? So if you're a normal, you got the instructions to make melanin from mom. And on your matching 15 from dad, you got instructions to make melanin. And now the cool thing about genes is since they come in pairs, even if one of your parents messes up and gives you the broken version, thanks dad, your other parent backs you up. So in this case, even though you have one broken, you're still gonna have dark eyes because you're still making melanin, right? Both of these chromosomes are working, right? To be a mutant in this case, like I am, you need to have this combo where both mom and dad pass down a broken version of that gene. And so I've inherited 2 broken versions. I don't make enough melanin at all in my eyes to be normal. And I have to live with this genetic curse for most of my life. Now, unlike Vincent or Jerome in the movie Gattaca, which if you haven't seen, you'll see today, this hasn't affected my life really all that much. There are lots of, some mutation and it's abnormal. There are lots of other abnormal mutations that would be much worse to deal with, that's for sure. We're going to talk about those a little bit in class over the next few days.